So today we're going to introduce a topic called the antiderivative. Okay, the antiderivative. So up to this point in the class, we've been taking derivatives. Derivative. Okay, so we'd say d dx, the derivative of some function plus a constant. Okay, so it'd be, x squared plus 5, 5x plus 8, whatever be the case. Some function plus a constant, a number. And that became a new but similar function, okay, f of x. Today we're going to introduce the antiderivative, okay? So the antiderivative is the inverse of the derivative operation. Okay, it's the inverse of the derivative. Okay, and what do we know about inverse functions? Well, inverse functions undo whatever the original function did. All right, so if you add 5 and then I subtract 5, I just undid what you did. Okay, because addition and subtraction are inverses. Okay, so and we have a symbol for this. Okay, it's this big curly loop, looks like that. That's the antiderivative. And we say the antiderivative of f of x dx, so the antiderivative with respect to x is equal to a new function plus a constant. Okay, so this goes this way, and antiderivatives go this way. It's literally backwards. Okay, so this is the symbol for the antiderivative. And it's also called the integral. And we're gonna call it the antiderivative for now. We'll work into that word later. Okay, and what I want to give you in this video is the rules. Okay, rules for antiderivatives. And I want to remind you that these are just going to be your derivative rules. But backwards. It's just going to be your derivative rules, but backwards. Why? Because we're literally going in reverse. We're literally taking the derivative in reverse. Okay? So, here goes. Rule number 1 for antiderivatives. The antiderivative of a constant with respect to x is equal to cx plus big C. Okay? Now, a way to think about that, okay, is if I gave you this. What's the derivative of 5x plus 8? Well, the derivative of 5x would be 5, and the derivative of the 8 would be 0. It wouldn't show up. So derivative would be that way, antiderivative would be that way. Okay? So that's the first one. The antiderivative of a constant is that constant times x plus some new constant. We'll get into that, what that plus c means to us in a second. Okay? Rule number 2. Rule number 2. The integral, or the antiderivative of x to the n with respect to x, is going to be 1 over n plus 1 x to the n plus 1 plus c. Okay? And then we have to add one thing we have to add n cannot equal -1. Why? Because that'd make this denominator 0, and bad things happen when you do that. Okay, so n cannot be -1. So I want you to think about the power rule. This is the antiderivative power rule. What's the power rule say? If you've got x to the n, the derivative of that would be n x to the n minus 1. So you're subtracting and multiplying. Another way is to think about the derivative of this. What would the derivative of this be? You would multiply n plus 1. Well, 1 over n plus 1 times n plus 1 would be 1. And you'd subtract 1, which would give you x to the n. Okay? So this, if you go this way, you've got your derivative rule. Okay? Rule number 3. Rule number 3. Okay? This is a very recent derivative rule in our class. So the antiderivative of 1 over x dx is the natural log of the absolute value of x plus c. Or natural log of x plus c if x is greater than 0. Okay? So if it's negative, you got to put it in absolute value. If it's positive, you don't. Okay? And then just one of those little hints that I want to throw at you. Sometimes we write this one funny. Sometimes we write this as the antiderivative of dx over x. So we put that with respect to x in the numerator because times 1. Okay? So don't let that trip you up. That's sometimes we'll write that way. Okay? And does this work? Well, what's the derivative of natural log x? The derivative of natural log x is 1 over x. So the antiderivative of 1 over x has to be natural log of x. It's the opposite of the original rule. Okay? And then fourth, our last derivative rule, the antiderivative rule that I'm going to share with you, is the antiderivative of e to the ax power. So some constant times x as the exponent with respect to x is equal to 1 over a e to the ax plus c, and a cannot equal 0 because, again, we'd be dividing by 0. So I want you to think about this. If you have e to the 5x times 1/5, what's the derivative? Well, it's going to be 5 times 1/5, which will be 1. And the derivative of e to the x is e to the x. Okay? So this way, you would get the derivative. Okay? So it's the derivative rule backwards. So those are our 4 big antiderivative rules. Okay? Now, if you remember your derivative theorems, I'm going to give you a few theorems. Okay, so antiderivative theorems. Okay, antiderivative theorems. Number 1, it says the antiderivative of a constant times a function with respect to x is equal to a constant times the antiderivative of the function with respect to x. And if you remember, there's a theorem exactly like this for derivatives, which said if you've got the derivative of a constant times a function, that constant could come outside of that derivative operation and be ignored. Go straight to your final answer. And we're saying that same holds true for antiderivatives. Cool. Okay? And then our second theorem is the integral of f of x plus or minus g of x with respect to x is equal to the antiderivative of f of x plus or minus the antiderivative of g of x. Okay, so what is this saying? This is our sum and difference rule for antiderivatives. So for a derivative, if you could add two functions and you were taking the derivative of them, you broke it into two separate problems. For the antiderivative, if you can identify two or more distinct functions and they're being added or subtracted, you can break that into two unique smaller problems. Okay? So that's the other thing you need to know. Now, the last thing you need to know, okay, the last thing you need to know is if I take the antiderivative of, let's say, I don't know, let's say the antiderivative of x, okay? The antiderivative of x with respect to x, okay? Or let's say the antiderivative of a constant with respect to x, okay? We already said that that was going to be equal to what? Antiderivative of a constant with respect to x was cx plus c. Okay? So, for an example, the antiderivative of 5 would be 5x plus c. Okay? And this guy here is called the constant of integration. Okay? And in any problem where you're just blatantly asked, find this, that's the answer. Okay? However, if given an initial condition, we're going to use that condition to find C's value, the value of C, okay, to find C's value, okay? And these are called initial value problems, or in math slang, you'll hear your teacher often refer to this as an IVP. Okay, IVP. Okay, and so if you hear that word, initial value problem or IVP, you know you can't have the letter C in your answer. Instead, you have to find the value. You have to find the value of that C and give that to me. Okay, and we'll do some initial value problems. We'll do some problems that are not IVPs. Okay, and then we will go in and see what can we figure out. Okay. So anyway, that's enough theory. If you have any questions about this, let me know. And we're going to do another video on how to apply this theory.